Okay, this goes back to March of 2015. It's to Derek Briggs, introducing my Mudfossils and asking for a correspondence, which he did. And I said how they're not like regular white bones. They're Mudfossils. The encapsulation was quick, cold, anaerobic, platypolar silicates, continuing wet conditions resulting in microcurrent fossilization, process literally electrical replacement, nucleophilic invasion, which I've gone over many times, of the original matter. It invaded it and it pushed it out and put new stuff in there. And a lot of it put new stuff, which was the silicon. That's a heart. That's been replaced by silicon. All right, and we're talking about that girl being replaced by silicon. And a lot of things have been replaced by silicon. Silicon in the veins of quartz, quartz veins in rock. Those are literally veins and arteries that have filled with silicates. Now, it says I said the process is electrical replacement, nucleophilic invasion. Now, because Ca2 plus is so reactive, the bone is replaced quickly with percolates in these wet conditions, yes. The preservation of soft tissue, however, is almost perfect in some cases, which is the Mudfossils, which I had. So I said, see Mudfossil process on my YouTube channel below, which was here. I said, this process is rare and it's such not well studied, therefore not well understood by mainstream science. It's not really rare. The University of Alberta proved the electrical currents, which are telluric currents. Forget about that, it means nothing. I have a YouTube describes the process, has examples of perfect fossilization. I would appreciate an opinion if you would be so kind. And now he claimed he looked at it and there was nothing there, they're just rocks. Now that was March of 2015. Don't forget, I talked about the platypolar silicates, wet platy silicate mud. That's silicate infused mud. The silicates is the key. That's what preserved them, mostly. Because feldspar wraps almost all of these. And that's made out of aluminum silicates. The silicates is the key. All right, these are all the emails to Yale about this, because I was kind of upset, I got to be honest with you. And Briggs told me I should go find a geologist. I showed you the introduction. Briggs' opinion after his review. All this stuff, it goes on and on and on. And I talk about, in my opinion, there might be some plagiarism here. As I will show you, his paper was virtually the same as mine. Refusal to respond. I talk about a lot of things because this is my opinion. And I think about fiduciary failure. These are supposed to be fiduciaries, Yale specifically, and, Professor Briggs as yeah, because I sent this to everybody. Yeah, here's the one right here. Briggs' response after my email barrage. Let's see what this says. All right, this was in December 2015. I did everything they asked for. I had DNA tests done, CAT scans, specimens, nucleophilic substitution, invasion, all figured out. And this was after I emailed everybody at Yale, basically. And he sends back, he says, Dear Mr. Spur, thank you for your email today and the attached materials. My apologies. Some of your emails have gone unanswered, but I know you have talked to Armand Morgan, which I did. Armand and I go pretty close here because, I just kept barraging him, but he just didn't pay any attention. No, he said, I have watched the video on your website and consider your results once again. Unfortunately, remains my view, these are not fossils but rocks that are similar in appearance to various anatomical features. Unfortunately, human DNA is everywhere, and any specimen that has been handled will yield gene sequences of bacteria and humans. I am not an expert on human anatomy or vertebrate paleontology. He's not an expert at anything that I can see, in my opinion. One strategy might be to find a geologist familiar with the rocks in your area. He's 15 minutes away, who could comment on your specimens. Nobody will talk. They all say, go to Yale. Talk to Derek Briggs. He's the guy. Perhaps there's someone at the Connecticut Geological Survey. I tried them. They won't speak. Nobody will speak. I wish you luck with your collecting and research. Well, no, I don't think you do, Derek. And the only reason you answered this time was because I sent this to everybody, including their legal department. And I said, you people have a legal obligation to your students. I would think that would be something they'd consider. No. And that was in 2015. Now, guess what? See, this is December 2015. Now, my paper talked about the silicon. I showed him my paper, I think. Let's see what he had to show. They turned it around so that it wasn't big creatures, which I showed Derek Briggs. In my emails, I sent him all kinds of pictures of the giants, and they were DNA tested and CAT scanned. And not a human being on the face of the planet could just dismiss them out of hand without examining them. I'm 15 minutes away. And arrogance was pretty heavy. So let's just keep on going here. All right, I know I showed you this from 2015, and then I had the DNA tests on the CAT scans. Everything he said I would have to do, I did. And he still dismissed it, as I just showed you. However, at the end of 2016, after all this time, at the end of 2016, guess what Derek Briggs did? All right, in my opinion, they took credit for my work. I sent all this stuff to Yale. Lydia Tarhan was copied into this too. Derek Briggs knew exactly what he was doing. It says Yale researchers studied this Ediacara. That just means soft tissue things from Australia when I'm 15 minutes down the street. Exceptional preservation occurred due to silica cementation. And they said it was very, very fast, possibly. Silica-rich oceans, yes. I explained that whole reason. And it's because we almost got hit by a fiery comet that caused the salacious ooze to come up off the ocean floor. Rapid cementation, just like this girl. Boom, preservation of detail. Yeah, they're just exactly like they were when they died. Role of organic matter. All right, help nucleate the silica preservation. Evidence for research, yes. Evidence from research, from my research, that's true. Significance of the research, it changes everything, except they turned it around. They turned the whole thing around to say that it was just little slimy sea creatures, and it was before there was even hard bodies. Exceptional preservation, soft-bodied organism. Crucial understanding evolution of early complex life. That's just not true. It's not true. They were not just slimy sea creatures. I showed Derek Briggs all of these things over and over and over and over. I did everything that they requested, and it was rejected and not allowed to. I couldn't bring him there. He wouldn't let me bring him. I said, let me bring him and show you. No, I've seen him. Go find a geologist. And then he wrote this paper. You see this? This tells the tale right here. Exceptional preservation, soft-bodied creatures from 2016, Lydia Tarhan, and Derek Briggs. Also NASA, the same thing. They had the same thing, the same time. Because NASA gave them all the money. I don't know if all the money, I think they hit a bunch of people. And this is all research. Lydia Tarhan, she's fabulous. Cementing a theory about sea creatures of the Ediacara. Well, there's that, and then there's their big fancy paper. Let's just look at this one. All right, cementing about it. This is exactly, and this was the time Derek Briggs published this paper. It says the earliest community of sea creatures lived in a warm, slimy petri dish that nurtured a broad array of exotic species. That is simply not true whatsoever. I presented body parts, bones. They say there was no bones. All right, bones. I presented a goose with his feathers and everything. This is what happened in this great flood because of the silicates. The silicates were the thing. This is a heart completely turned into silicates, basically. There's a little bit of blood left in it. The left superior, or the superior ventricle, whatever, something like that. That's a heart. And there's a ton of stuff that has turned into silicates, and I think pretty damn quick in a lot of cases. And they're talking about this was all supposed to be before there was even any creatures that had bones. The earliest complex creatures in a warm petri dish. This is so that they can support evolution and say there was no God, nothing. I told Derek Briggs that I had giants, and I had them DNA tested and CAT scanned and anatomically analyzed by real people that were interested, and he just absolutely refused. In my opinion, that's if I was a student, I would not be happy that he knew this stuff and didn't engage whatsoever. And then wrote this paper and got funded by NASA, who I also contacted at the same time. All I could think is that NASA went to Yale and said, is this guy crazy? And they said, no, but it's only slimy things. Now listen to this. The Yale-led research team found a collection of marine and sandstone. No, it was mud. The finding appears in the journal Geology, and they say that the Ediacarabota takes its name from a fossil deposit in South Australia. No, it should be right down the street. I'm right down the street from Yale. I'm in Connecticut. I'm 15, 20 minutes away. The fossils of the Ediacarabota are found worldwide. They're everywhere because it was a gigantic flood. They're worldwide because it supersaturated the oceans, and they say that. And they say it was 540, 580 million years ago. That's not true. The creatures that were small, as few millimeters large as a meter, and lived on the communities on the sea floor. The whole world was a sea floor at that time, and this is not true whatsoever. These things were body parts, and I have a lot of them. And here's another one that's DNA tested. Right there, it's a human lung. And it is DNA tested, and it is human. And I drill inside of them. I don't take anything from the surface. And it's flat as a pancake, which all my stuff basically did end up boiling off and laying flat. Just like this. This is another lung. That's all the pleura, which normally coats the lung. It's like a big rubber bag. It's pushed off this way and this way. And that's the strap that holds it in place. And that's flat as a pancake too. Now, I'm right down the street from Yale. Now listen to this. All right, listen to this. These creatures they say there were slimy things on the sea floor. Well, many of them are outright bizarre in appearance, do not resemble any organism alive today, said Lydia Tarhan, a postdoctoral fellow and first author of the study. Quotations, we would like to understand their relationship to the complex animals that evolved shortly thereafter. Are these soft-bodied creatures some sort of failed evolutionary experiment, or do they include ancestors of the animals that subsequently colonized the oceans? It was a failed experiment, and they killed the giants, and I have those giant body parts here, and here's a hair follicle from one. That's the muscle. That's the sebaceous gland. That's the hair shaft. That's the hair follicle, 2 inches wide. And I have all the ones DNA tested, a 3-inch long fingertip. DNA tested. A big part of the answer involves how these fossils were able to form. They're entirely soft-bodied. That's not true. They lived before evolution of shells, teeth, or bones. No, the bones were here. The geese were here, the giants were here, everything was here. And they say those are the only things that normally get fossilized. No, and they know that now. They understand it, but they want to twist it into being just jellyfish. All right. What the researchers realized was the oceans during the time were much richer in dissolved silica, and which is what caused that bride to turn into stone, I think, and that may possibly be true. So they were supersaturated. It's because there's a layer on the ocean floor called the siliceous ooze, and when the earth was wrenched, all of that stuff came up, caused giant floods everywhere, and silicon, and the three layers, the red bed, the gray clay, and the black cap, was all from this impact. And it was actually a boiling impact. I thought it was cold when I first originally thought about it, but now I realize it was a boiling hot event which boiled the oceans, and that's what Velikovsky had. Anyway, they were, this is in quotations, these organisms, these soft bodies, were rapidly buried during sand, which is not true, it's mud, underwater storm events. What underwater storm events? Tarhan noted this process of cementing the sand grains, mud, around them must have happened rapidly, because otherwise by the time the carcasses rotted away, the sand bearing them would have simply collapsed into the hollow left by the erstwhile carcass. Well, that's erstwhile carcass. Interesting. The team conducted the research using detailed microscope-based techniques, exactly what I did, yes. The research were able to measure elemental compositions. Now, who was this? Derek Briggs, the same guy I gave all my stuff to. All right, and this is he's supposed to be Yale's Evelyn Hutchinson Professor of Geology, Geophysics, Curator of Invertebrate Paleontology at the Yale Peabody Museum, Natural History. Then they had all these people. The research is supported in part by National Science Foundation, Earth Sciences Postdoctoral Fellowship, a grant from the American Philosophical Society, Lewis and Clark Fund, a NASA Exobiology grant, a NASA Postdoctoral Fellowship, and the Foundations of Complex Life, NASA Astrobiology Institute. NASA, I wonder how much they gave them. They funded them. Well, I did all this research already. And I contacted NASA because it's on Mars. The same exact stuff that's here is on Mars, and it's biology. And they still won't acknowledge it. And they just came back from Bennu 2 years ago with heart muscle, and they still won't acknowledge that. They say, oh yeah, everything's there, the DNA, the uracil, RNA, the clay, the everything, the membranes, the sarcomeres, which is a muscle, it's all there, but they can't accept the fact that they landed on a heart and came back with it. And it is a heart. Above that, there is no question. So we're living in fantasy land, my friends. See, this was a big deal for Yale. I mean, I have no idea how much money they got. But this is all about a high silica content of these soft-bodied fossils. Fossil study sheds light on ancient seafloor life. No, this was ancient life on the face of the planet that got covered with a flood. That's all it is. It wasn't seafloor, but it was basically almost like the earth was covered with a sea at that particular time. And then they sort of settled out, and the land came back to being land, and the oceans and the rivers and so forth went back to being oceans and rivers. But in the meantime, it was a complete worldwide flood, and everything in the ocean went all over everything, and a siliceous ooze came up from the ocean floor and created the silicon. That's where the silicon content came from, high silicon content, and they have no idea why. All right, this is where all the silicon came from. The thickness of siliceous ooze varies significantly, because the deeper it is where it's going to settle. All right, accumulated layers growing very slowly, rate of less than an inch per millennium, never mind, 1,000 years. In some areas, the layer is only a few centimeters thick, while in other areas it can be hundreds of meters thick. total thickness of ocean floor sediments, including siliceous ooze, can range from millimeters to kilometers, miles basically, of this siliceous ooze. The whole earth did this. So this deep, deep stuff came up, and it was just super saturated, and there was a ton of it. And she must have got a ball that was invaded with this super saturated silica ooze. And she just chugged it. If it was true, if that thing was true, now it all makes sense to me, understanding the biology and the chemistry and how quick things can move through the body. And even Yale says, yeah, it can happen within hours. Hold on. You see this? You're talking about the supersaturated dissolved silica and enabled the transformation of sand. No, it was mud surrounding these creatures, making those animals turn into rock over a matter of hours. Or possibly years. It depends on how supersaturated the water was in that little bowl. Now she had something that probably filtered everything out except the silica. I don't know. But it could be a true story, it could be fake. All right, what I am going to do is play this one, my original one that I did, which is, well, it's 43 minutes long. But I went into extreme details because I felt it had some validity to it. And this was a year ago. And I'm starting to get people asking about this. So here it is. You want to know? Here it is. Okay, my friends. You know, I often talk about Immanuel Velikovsky, which is my hero. I wrote a book about him 10 years ago. It was published in February of 2016. February of 2016. And I called it Minds. Well, I called it Mudfossils and Velikovsky and Minds in Collision. I presented all my evidence to Yale University, to all of the big universities, Yale primarily, because I'm right down the street. And I'm going to explain to you what did happen. And this was in my frustration. I wrote this, and that was 10 years ago. So let me explain to you what has happened since then to now about mud fossils, because that's what I presented to him, was exceptional preservation due to these conditions. I'll show you the email I originally wrote to Yale, to Derek Briggs, and then we'll follow it down, what has happened since then. Okay, my friends, I already got an update on the girl that turned into stone from drinking the silica, which was inside of what you might call a geode, whatever you want to call it, those round balls. And they could hear it slushing. They cracked it open, she drank it, and very quickly she turned into stone. Primarily, you know, rigidified enough to where they have a very hard time apparently using the scalpels, and they dulled the scalpels. Normally they cut through the tissue, it's not too hard. And she just got rigid, basically turned into stone. So I was thinking about it, you know, the silica moves pretty quick, and if you can get it into your system fast enough, it should move just like drugs do in your body. They move quickly. Within a couple of minutes, they've been flushed into your system. It doesn't take long at all. And silica is one of those things that just travels. It's a very, it's almost like carbon, a little higher up on a periodic table, but I think it has a lot of attachments that allow it to move through the body, doing a lot of chemistry, so it flows easily. And she drank it, and within, they claim 15 minutes, 45 minutes, she was pretty stiff. So I started to think, the mud fossils, they died, but in a different manner. However, according to the ancient texts, we were almost hit by a fiery comet, and it literally boiled the waters in the oceans and spewed up all this really heavy-duty silica, supersaturated. Now, that I would assume would go into your lungs at some point, whether or not you breathe it in or swallow it or whatever, as you were dying and boiling in this supersaturated silica, which was the condition at that particular time. And that's what led to all of this really spectacular gemstones and all that stuff. It was from a boiling hot flood, and where the blood was primarily, you get all the colors, because those are the transition metals that give off the colors. Now, Yale University says that it enabled the transformation of loose sand to turn animals into rock to occur over a matter of hours. Now, first of all, the sand is a product of silification, silicate into blood cells and body tissue, basically. Turn it into sand. Little bits and crystals of the silica attaches to the body chemistry, creates sand. That's why you see all these different colored sands all around the world. They were in different places where they had different body chemistry, creating different inclusions in the silicates that attach to the body tissues, which in this case would be blood cells primarily, but other things too. Flesh, let's go with flesh. A lot of it's going to be connective tissue. There's going to be vein blood in there. There's going to be artery blood in there. There's going to be a lot of different mixes. That's why you get sand of, you know what sand looks like. It's got the black and the reddish looking stuff. And it depends where it comes from. Some places the sand is just almost like blood red. Some places it's white. Depends on the chemistry. It depends on how long it's soaked. It depends, a lot of different nuances that I have picked up over the course of this time. I've been 15 years doing this now. And, I'm not... I do a little chemistry, I do a little this, a little that. So I understand the whole thing, the biology, the anatomy, the chemistry, the enzymes primarily. That's the most important thing in your whole body is the enzymes, and that's from the bacteria. Health is good at bacteria in your body. Enough is said on that. Now, this is what Yale had to say. They say it could happen within a matter of a couple of hours. And at first I was thinking, but if you inhaled that stuff or it got into your lungs, that's where all the blood is. That's where the transfer of the artery blood would pick that up and move it right around your body very quickly. Dead or alive, I believe. It's not going to pump when you're dead. I don't know. It's a tough thing. I wouldn't say it would happen within hours, but Yale says it could. I did say to them it could happen in hours. All right, so here it is. I wrote this paper in 11/30 of 2015. Fascia facilitated fossilization, and that's why, like fascia coats everything in your body, every organ, every muscle, every bone, every tendon, and it's a membrane. Let's go with membrane. Just call it a membrane. It's like a rubber coating. All right, and it allows things to come in and things to go out. Very specific coating, and it's very, very durable. During the mud fossil process, the membranes stayed pretty well. They didn't go terribly bad, even in the boiling conditions where things turned like this, which is DNA tested, and CAT scan, which is a human lung. All right, that, you see how flat that is? That's because it died laying flat like this. And all the flesh boiled off, but look at how perfect that pleura is. Pleura is the coating that is around your lung. It's you know, it goes, and it's like a big heavy-duty fabric. Look how perfect it is. It's flat though on the back. And it died with the heart intact. And I know that because of this curve right here. You should be able to see that curve. That's where a heart was, right there. That's exactly where it is, right underneath your left lung of a human. And that's where the aortic arch would be, and it was there. Right there. And the heart's separated. And the hearts are staying pretty good tact too. This is absolutely flawless. You can almost transplant this. And I took blood out of here, you know, raw red blood. It came out. I extracted it, sent it off, and had DNA tests done and all that. By the time I wrote this paper, it had already been DNA tested and CAT scanned and all that stuff, because I was getting no results from anybody. So I go through the whole thing, da-da-da-da-da. All right, and I talk about it being somewhere down here. Yeah, fascia is a tubular fluid-filled fabric network. It goes around your whole entire body. It instantly reconfigures itself if damaged. It could be fiber optic. At this point, I knew it went through the entire body. It was a fluid-filled highway. It comes together as one giant system. There's all kinds of different collagens and keragens that protect you from acids and so forth, and these are very infused with silicon. The silicon I talked about a number of times, and that is what feldspar is made out of, is aluminum silicates, and virtually everything is coated with feldspar. It's everywhere. It's like, most of rock they consider it feldspar. It's the coating on rocks, which are the membranes. Feldspar is made out of keragens and keratins. Feldspar, aluminum silicates. All right, so this is in the timeline 11 of 2015. I was very, very frustrated because I sent this to everybody. I presented this, which was the DNA reports. Those were done in September of 2015. 3 different samples, and 2 of them were from giants. I extracted the samples, put them in glassine bags, sent them off to Helix Biolabs. It was done very carefully. You know, I'm not an idiot at doing this stuff. I was careful. I made sure that it was not contaminated, and it was dense with DNA, 2 out of the 3. This was dense. Excellent quality DNA. It's still got red raw blood in there. I show this in a microscope sometimes. I just put a little water on there, it rehydrates instantly. I scrape it a little bit and it just starts bleeding. This thing is still saturated, full of blood. I had other ones that actually had blood leak out of them. But anyway, this was done, and this was a very sophisticated test. And they, all kinds of fancy stuff they do with different, you know, elutions. You know, it's sophisticated, let me put it that way. And they successfully found all of the things they were looking for. 2 of them were dense, the other one not dense. But I'll show you the stuff in a minute. What they did was, it says excellent quality was obtained from the 36-inch tip and the lung. This is the lung, excellent quality. I mean, it's just raw red blood. And then this is Homo sapien mother side. That's all. That's all I wanted to know. I didn't want to know anything special. I didn't want to be able to clone it or any of that business. And here's what they found. It's a Homo sapien, whatever it was. It's just, I said, is it a modern human? He says, yes. Just the same is from a modern human type mitochondrial DNA, which we all have that same little snip in us that signifies that we are that species. If it wasn't the same, we might be Neanderthals or Cro-Magnon or whatever, they give them something else. But there's DNA is nothing more than a program. And I mean, I'm serious, it's nothing more than a program. And if you and you change that program here, you're going to have a jaw that comes off this far, or your ears are going to go this way, or whatever it is. That's all it is. It's a construction program, basically. It does its job of making whatever happens to you to be human. So you got so many toes and fingers and all this business. And this is the mother's side that apparently all I can think of is like the core. All right, because if it's the same in everybody, which apparently it is, just whatever snip they took, that's significant to me. That means it's in every one. The rest of the stuff, I don't know if I don't know if it is or not. But if there's one particular thing on the mother's side only, is always the same, always. And we're always derived from a mother, so we get that snippet. Male, female, doesn't matter. But it says we are a human Homo sapien. And this was a serious test. And I talked to Tom about this, and he was getting pushback from people that didn't like him doing this, and saying, "Oh, it must have been contaminated." Well, he said he would stand behind a test, and I still have these things. They can be tested again. They can be tested again, and they're just completely, totally obvious anatomically. And he said he stands behind a test. The only thing he wants to be certain that you understand is Roger Spur, me, not him, not Tom, me, took the samples and I sent it to him. If I contaminated him, I destroyed him, whatever I did, I faked it, not his issue. He tested what I sent him, and he says I stand behind those tests. Now, I still have these things here. They can be tested. You just drill another hole in there. Just drill deeper and find it. That's all I did. I didn't do anything. I didn't scrape it off the surface or anything. That's all. Oh, he must have contaminated. That's what I got from everybody. And, you know, in my opinion, it was just so that they wouldn't address these crazy things I had, which were giants. And here's these giants right now. Don't forget now, 3 DNA tests I had done. Let me just show you what they look like, where they came from. You know, I want to tell you something. I wasn't going to do any of this. I wasn't going to hand this off to Yale. I sent this to Derek Briggs. This is from March of 2015. This goes back 5 months before I had my DNA test done, because I couldn't believe they wouldn't work with me, showing them what I had. Anyway, I told him exactly how it happens. They're the silicates, the silicate mud rocks. And I said they always thought they're not to contain fossils. I'm right in Connecticut. Anyway, I go through the whole thing here, and I say it's a perfect fossilization, absolutely perfect. I say it's calcium 2 plus 2, very reactive in solution, and it's replaced quickly with percolates in the wet conditions and these platypolar silicates. I say the process is rare. It's not rare, but it was not well understood, and I say that's still the case by mainstream science. They won't look into it. And I had the examples, perfect fossilization, I said, would you look into it? And he did say that he looked into it, and it was just rocks, there's nothing there. And I kept going back and forth with him. I got a list of emails this long, going back from Yale and back and forth. And so I had the DNA done and the CAT scans done, and the CAT scans too, not just the DNA. I had everything done. And I was so frustrated that by the end of the year, I wrote the book. Now, I was still in 2015. It was published right at the beginning of 2016. Now, let me show you what happened after that. This is what really upset me, was because Velikovsky was destroyed by academia. They did the same thing to me by not engaging with me. All I wanted to do was hand it off. This is 99 cents. This was my book, Mudfossils, Velikovsky, and Minds in Collision. Their minds just collided with reality. They still can't accept it. This is more than 10 years later. Now, like I say, it's not 99 cents, but you don't get anything. However, a friend of mine writes books, and I agreed to let him just write whatever he wanted, just put it in about my book, and he did. And I had a very negative tone at that point. I say, how could academia be so completely wrong? How could they be so arrogant and go along with the bullies simply to have friends and get along? They would not work with me at all, none. So this is basically my paper, my book, and he put it into just a small book here. It's something you can throw on a coffee table, but it's about Velikovsky. Now, I have a lot of information about Velikovsky, and I'm going to be doing a complete series on him, which is going to be extensive. And it's just so beyond belief what he had turned up. They forced him to take his books off the bookshelf. They made him take his books off the bookshelves. And it was #1 on the New York Times bestseller list 11 weeks in a row. And academia told him, the publisher, if you don't take it off the bookshelves, we'll never buy another book from you. And they took it off. And that was Worlds in Collision. It was about Venus hitting Earth, or almost hitting Earth, causing this cataclysm. And he went through all the things, all the way back to the Egyptians and how the cycles of the Earth and so forth go. There was a lot of history that we just thought was just silly. Now, Mudfossils has changed all that. And I had the stuff to support Velikovsky. And I said, I have the information that proves he was right. Mudfossil specimens are physical support for Emanuel Velikovsky's historical masterpiece, 1950. And I was really upset at this point, and I rightfully so. And primarily about from Yale. I was really, really unbelievable. In my opinion, it was not the way to respond for an academic place with the physical evidence I had. Now, this was 10 years ago. These kids have all been taught stuff that I don't know what they're teaching down there. But if they're not teaching what I showed and I presented, or even discussing that, I would say that that's not a good fiduciary. To have that evidence in front of them and have it be ignored, that's a fiduciary failure, in my opinion. All right, you see this? This is Derek Briggs. He's the guy that I said I sent all my stuff to in 2015. Now this is 2016. They're announcing a new paper about exceptional preservation of soft-bodied creatures promoted by silica-rich oceans. Exactly what I sent to him. And it's virtually the same stuff. It's just all puffed up so that they make it seem like they did something special. Now, on campus, though, they wrote this at the same time. Remember now, November 2016. Now this is on campus. They wrote about the stuff that I sent to them, basically. Animals themselves, but I said no, the animals were real and they were gigantic. They changed everything around to say that it was only slimy creatures. But they say it was all over the entire Earth. There was oceans, so it had to be a worldwide flood. Obviously, something happened there that it covered the entire Earth at the same time with the silica-rich stuff. And it says, because of this, fossils were able to form, but they say they were entirely soft-bodied. They lived before an evolution of shells, teeth, or bones. That's totally wrong. I got bones, I got everything. Teeth didn't do so well. Something about the teeth, I don't see too many of those, to be honest with you. Every now and then you catch some, but not very often. It's the fleshy stuff. For some reason. Even bone didn't do well. Bone, if it was exposed all the way down to the bone, it was gone. Now this one had to be inside of flesh or something deep in the mud, because the mud is almost just like, all this is eroded flesh. That's all mud is. Even today out there, that's basically what it is. It's eroded flesh. It's organic material that's rotted down. You know, a lot of it now is foliage that's on top. But you dig down a foot or so, you're down into the creatures' bodies. All my stuff came right off the top of the earth, basically. I didn't dig hardly for anything. Let me show you the things that I did submit. Now, don't forget, this is about Yale. This is from Yale, from Lydia Tarhan and from Derek Briggs. And they're talking about, they want to understand if there's anything that relates to what we have alive today. Because they say this was before there was any bones. There was no bones. We lived in a slimy petri dish. Look, this is what they want you to continue to believe, that we all came from a slimy planetary petri dish. You see this? And I submitted all my stuff to Derek Briggs, who was part of this paper. This goes to October 2016. I sent him all my stuff, and I had my DNA reports and all that stuff done, CAT scans and everything, submitted to him before this. Now, he says, yes, this can happen, but it's only from slimy petri dish stuff, because that was before there was any life on Earth. And that's how we evolved from it, from 540 million years ago. That's not right at all. And he's saying that it was worldwide. All right, these creatures are found worldwide. 540 to 580 million years old rocks. Then he says they were as small as a few millimeters, as large as a meter, lived in dense, diverse communities on the sea floor. Well, worldwide, what does that mean? Worldwide sea floor. Because everywhere. They're everywhere on the surface of the Earth. And then they're saying many of them are bizarre. Yes, they don't resemble any organism alive today. They think it might have even been some sort of failed evolutionary. Was this some sort of failed evolutionary experiment? Basically it was, but it continued on. They didn't all die. So they're saying all this, but the deal was much richer in dissolved silica than today. They get turned into rock over a matter of hours or years rather than the normal time frame. And they say they were rapidly buried by sand during underwater storm events. No, by one worldwide flood. It was worldwide. It was everywhere around the world. Now, guess who paid for this? Don't forget, Derek Briggs is the guy I sent all my stuff to, and there's really nothing different except they say it was sand. I say it's mud, and it is mud. They're wrong. I am right. Derek Briggs has got all these titles: Yale's Evelyn Hutchinson Professor of Geology, Geophysics, Curator, Invertebrate Paleontology, Yale, blah, 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 and all of these other people, which I submitted all my stuff to all of these people. I sent it to all the people in Yale, all the way up to the president, over the course of this time frame. And guess who paid for this? All right, National Science Foundation, Earth Sciences Postdoctoral Fellowship, grant from the American Philosophical Society, Lewis and Clark Fund, NASA, Exobiology, NASA Postdoctoral, Foundation of Complex Life, NASA, Astrobiology Institute. I contacted them at the same time I contacted Yale, which was years earlier than this. And apparently they went to Yale and paid Yale to see what I talked about, because I actually contacted NASA about this as well, because Mars has the exact same geology as Earth, and the geology on Earth is biology. Same thing on Mars, totally ignored again. But every day you see, oh, we might have found something, we might have found something. I found it years ago. All right, here's my proof that I contacted NASA. It was Michael Zielinski. Now this goes back to January 2016. Don't forget, Yale in November or October, whenever, of 2016 made their announcement of mud fossils, only they talk about sand and them just being slimy things. Now I sent this to NASA. I said, I have physical evidence, multiple available specimens, had 3 DNA tests, 7 CAT scans, experts, chemistry, lab recreation, preservation, process, and documented, and videos. I had all this stuff I sent to Zielinski. The DNA reports, everything, I had everything. Now, I find it almost impossible to believe that he just accidentally bumped into Yale at this, and there wasn't something going on because of my reporting to NASA. Because the stuff on Mars, identical to the stuff on Earth when you understand mud fossils. But because Derek Briggs said, no, only slimy little creatures, and that was before bones and all this stuff. So that sort of just, you know, in other words, they wrote me off as a nutcase. Because of the giants. That's the key. It was, and all that stuff is true. Okay, this is a lung, and this is a lung. This one is stripped down all the way down to where you can see the alveoli, all the little holes. And there's actual blood came out of there. When it came out of the ground, the blood leaked out of it. This one here still has all the pleura on there, which this one has no pleura at all. They come in a whole variety of ways. I have some that have some pleura, and some part of it has no pleura. It depends on how the conditions they were in when they were preserved. Now, this had excellent quality DNA, and it was DNA tested and CAT scan. Now look at this. This one here is a giant fingertip. All right, it's too big to move. I could see the fingernail was here, and it was perfect. I mean, absolutely flawless. And I could see the cartilage here that is right in the back of your bone so that the next one doesn't rub on it. And I could see the vein and artery coming in. And I could see the structure of the finger. And I got to admit, I didn't see at first the fingerprints, but they're there. It was so complete, it was like perfect. There was no place I could go in to get DNA. So I smashed this piece off, and it popped right off as a scab. There's no real fracture there. It was just like, almost like glued. And it's called grip skin. And here it is right here. This is what popped off. You see this? That is a sweat pore. That's a sweat pore. This is the fingerprint ridges, the same as you have on your fingers and mine. My thumb is about as wide as that right there. You see that? This is what this is. It's this really heavy-duty grip skin. And it just popped right off of there. And I got down here as red raw blood, and I sent that off. These two had the excellent quality blood, was this big jobber here. It's 3 feet long. That had the best quality of DNA, as did the lung, because the lung was just nothing more than red blood. I mean, when you get inside there, it's just blood. I've shown this many times. Put a little water on there, scratch it, blood just runs right off. Blood rehydrates very, very quickly, and it's an excellent preservative. Now, this was the one that didn't have the best DNA because it's completely transitions into mudstone. All right, well, let me just put it this way. This was the red fleshy stuff on your left hand. All right. This is that grip skin that I talked about. It peels right off. That's on your fingers, your palms of your hands, and all that. You have the same thing. It's like a rubber glove. It's grip skin, friction skin. It's the tough stuff. It's not like your face. Now, then you have this cleave that's in here right between the pads of your hand. Your little finger runs off to this side, and your thumb goes off that way. Now, and that tendon right there, if you lay yours back, you have the same thing. You can feel it if you go back and forth like that. You feel it right down the center. Now, and I have some of the fingertips, which I did have CAT scanned. I had 7 CAT scans done. Jesse Garant and Associates, the best people in the world. Literally, as far as I know, the best people in the world. They do for everybody big shots, the real big guys. And they were intrigued. And they offered to do them at no charge. And they did 7 CAT scans. I just had to have them shipped there and shipped back. I paid. That's all I had to pay for. And they were, you know, about this size. This one here, and the fingertip is a little bigger than that, but not much. Here's the fingertip. Well, that's the CAT scan of it. They did 2D and 3D. The 3D, you don't get so much because it was completely nucleophilically transitioned. That's why I didn't get a whole lot of real good red blood out of it. And I actually didn't take it from the best spot either. I took it out of an artery, but it was an artery that was... Anyway, this is the bone. Tendon, tendon. Blood supply right there. Blood supply right there. And don't forget, this is what freaked them out. At all the universities, they refused because of this stuff. The giant, that hand there is 4 feet wide at the top, about 3 feet wide down here, maybe a little more. 4 feet at the top. The fingers, I showed you, the fingertips are, you know, they're pretty, well, as a matter of fact, hold on. I got one around here, this. All right, this one of the fingertip tips, right at the very, very end of the tip. And the fingernail would be right there, and all that stuff has eroded away, most of that stuff. That's the bottom of the finger. And that little notch right there is where the tendons lock in. There's 2 tendons that lock right in there. And that lets your finger do this and that. All right, now, and from the back, you can see the bone and you can see the vein and artery and the tendons, which I just showed you. And that's a 2D. That's the best, is the 2D. Because you can get the surface, you can see it's pretty obvious now. That's a tendon. You see the circle here? You see that little dot right there? That's where I believe the artery ran. And that's the cord that runs up with the tendon. Now this is the bone. And of course it's eroded. And this is the other side. See, this one's white. And this one here is black. It's 2 different types of blood. And they have different colors. And it depends on what it bonded with and what it didn't bond with, gives you the colors. But primarily I see the vein is almost always black and the red is almost always red. I mean, the artery is almost always red. And the arteries stay open and they drain out. Veins, that blood seems to harden up hard and it doesn't move. Arteries stay rehydratable forever almost. I put water, like I said, I could put water on there and get blood coming, actual red raw blood coming right out of there. Almost instantly. You see, there's another 2D. You would never see that. That's where the fingernail bed was. Right there. Remember that notch? That's where that notch is, right there. And there's tendons that lock right in there to make your finger be able to articulate and move around. Now, again, that's 2D. And you can see things that you would not normally see because of the way they take it from every different angle and shading. And again, see that right there? That's this right here, see? That's that right there. That's this hook where the tendons lock in. Here's the bottom. Right there is what's called an apical tuft. I got one around here, hold on. You see that? That circle right there has a ton of little holes in it. And this one is the same. This was probably, well, I know it's almost undoubtedly from the same hand. I have ones of the fingertips, that, like this one here, is in very good shape, as best as you can expect. I drilled a hole in there. Now, this is where the apical tuft goes. I have the knuckles and so forth from this highly eroded, and where you can see the bone ball, you can see the tendons, you can see everything. But that's an apical tuft, and that again has all these little straps that come out. If you look carefully, you can see the little straps coming out, and that strap and ball is still here. They come and they hook in all over. You see all those little bumps? That's what happens for your apical tuft, to make your fingertip to be able to wiggle around. So I hope the reason I have this green thing on here is because I broke this piece off, which is right next to the bone. So I want to keep it together. All right, remember this one? Now that's about 3 feet long, fingertip. Now I think this is a hair follicle, and I think this could be from something, it would at least be that big, I would say. Now there's the erector pili muscle. You see where it attaches right there? And now let your hair go up on end like that. So this is like on your arm or something. There's some of them don't have this. Your hair on your face doesn't stand up on end. The hair on your arms does. So that's, in other words, you can find ones without that. This just happens to have a muscle. Now, this side is the sebaceous gland. That's where all the gooey stuff oils your hair. And here's the hair shaft, comes up the top. There's all kinds of little layers of clay, which is, your face is made out of clay, basically. Now, that's the root coming down. And that's the red and the blue for the blood, where everything's got to be serviced with blood. And this is it. And that's the orientation of it right there. So this is 2 inches wide. So that's a pretty good sized guy. Somebody did the calculation. I did too, but I can't remember. It's big. You figure it out. So now, I got a variety of sizes here. This guy's fingertip is 3 feet long. This guy's hand is 4 feet wide. So you add another foot to this, and you got a whole hand. That's crazy. But I got all the bits and pieces, and it's CAT scanned, DNA tested, the whole 9 yards. And I got them our size too. This is just basically the same size as us. That could fit in a person's chest, basically like a normal lung. I don't see any difference between how big I would be and have that lung. Maybe this is a little bigger. I don't know. It's pretty damn close. It's a lot closer than having a hand this big. The lung would be much, much bigger. The lung would be 4 or 5 feet wide. You know, you take your hand and put it on that lung. You see it? And then think the lung would be a little bit bigger than this in your chest, and that's 4 feet wide up there. So that's a pretty good sized lung. And you have 2 of them, hopefully.